Hello everyone, I welcome you all to my channel. In this video, we are going to see the topics from Unit 4 of Embedded and Real-Time Systems. So in this unit, there are 6 topics. There is structure of a real-time system, estimating program runtimes, task assignment and scheduling, fault tolerance techniques, reliability, evaluation, and clock synchronization. So in this video, we are going to discuss structure of a real-time system. So first, let us see what is a real-time system. So real-time system means a system should work within a specified time period. That means a particular time interval is given. So within that time interval, the system should process a task or complete a task. If it doesn't complete the task, the system will fail. So this is called as a real-time system. For example, consider in a chemical plant there is a boiler. So a boiler's temperature should be noted each and every second. So there will be a sensor. So this sensor is used for monitoring the temperature of the boiler at each and every second. So when the temperature exceeds a particular limit, then immediately the information should be sent to the control room. So this is the system. So if the sensor fails to record the temperature or measure the temperature means, then what happens? The temperature of the boiler increases beyond the limit and it may cause a very big damage. So our system should operate in a real-time environment. So another one example, DVD player. So in the DVD player, it is also a real-time embedded system. If we press a play button in the remote, then immediately the video should be played. So if we press the stop button in the remote, the video should be stopped. So whatever button we are pressing in the remote, the immediate action will be performed in the DVD player. So this is also an example for real-time system. So there are two types of approaches. The first one is event-driven approach and the second one is time-sharing approach. So event-driven approach means in this type of embedded systems, the task will be done based on the priorities. That is, in an embedded system, there will be multiple tasks. So each task will be processed or performed depending upon its priorities. So it is called as event driven approach. So if some task should be performed first means, then the priority will be given to that task and that task will be performed first. Then the next task, like that it goes on. The second approach is called as time sharing approach. So in time sharing approach, in this type of embedded system, the task will be based on the clock interrupts. That is, depending upon the time interval, the various tasks will be performed in that embedded system. Then we are going to see some applications, industrial applications, medical applications, telecommunication applications, consumer electronics. So everywhere we are using this real-time embedded system. So this is the structure of a real-time system. So here sensor is the input. So from the environment we are getting the data and it is given to the input conditioning unit. Then there is an input interface, then real-time computer, output interface, output conditioning unit, then finally actuator. So here there is a human computer interface also. So this is to directly operate the real-time computer. So first, let us see sensor. So sensor is used for sensing the data from the environment. So from that, the data are given to the input conditioning unit because we cannot directly give the signal to the real-time computer. So first we have to condition the signal. So at the input side as well as in the output side, we are having the condition unit. Then there is an input interface and output interface. So this input interface and output interface is used for converting the electrical signal into a digital signal, that is analog signal into digital signal, because real-time computer can process only the digital signals. So we have to convert the analog signal into digital signal. The sensor will give an electrical signal as to the input conditioning unit. Then using the input interface, it is again converted into digital signal and it is given to the real-time computer. Similarly, the output interface. So this will convert digital signal into analog signal. Then again we are using output conditioning unit for conditioning the output signal. Then finally it is given to the actuator. The actuator may be a simple motor, just it will run the motor like that. Any applications we can use it there. Then human computer interface. So human computer interface means we can directly interface with the computer and we can change the operation. So this is the structure of a real-time system. So sensor, so it converts some physical characteristics of its environment into electrical signal. Example, photovoltaic cell, temperature sensor, humidity sensor. So everything, it will convert it into electrical signal. Then actuator. So actuator, so it converts electrical signal into physical action. The best example is motor. Then signal conditioning unit, we need input conditioning unit as well as output conditioning unit. Then interface unit. So interface unit is used for converting digital to analog or analog to digital signal. So next we are going to see the timing constraint. So before going into the timing constraint, we should know some definitions. What is job, what is task, what is release time, what is deadline, and what is response time. So first let us see what is job. So job means unit of work that is scheduled and executed by a system. That means a single work, small, that is only one work. It is called as a job. So a collection of job is called as task. So this is a task done by the embedded system. Then release time. So release time means it is the time at which the job becomes available for execution. That is when it gets ready for execution. So this is called as release time. Then deadline. So deadline means we know that is the particular time the all the execution should be completed. So that is called as the deadline. Then response time. So the response time is the length of time from the release time of the job to the instant when it completes the job. So next one is relative deadline. So relative deadline is the maximum allowable response time of a job. So this is the relative deadline. Then absolute deadline. So absolute deadline means release time plus relative deadline. If we add these two time interval, you will be getting the absolute deadline. Then timing constraint. So it is the constraint imposed on the timing behavior of the job. So this is a very important thing, timing constraint. So next we are going to see the timing constraint types. There are two types of timing constraint. One is hard timing constraint and another one is soft timing constraint. So hard timing constraint. So hard timing constraint means within the deadline, if a job fails to complete it, then what happens means there will be a disastrous consequences. So this is called as hard timing constraint. So within that deadline, the job should be completed. If it does not complete means then there will be major consequences. So if we go for soft timing constraint, here if the job doesn't complete within the deadline or it takes some more time, more than the deadline also, there will not be much consequences. That is, for example, the same example, that is boiler. So if we are taking the, if a sensor is used for sensing the temperature of the boiler each and every second, so it should monitor it correctly. If it does not sense the temperature for a particular second, what happens immediately? The temperature of the boiler increases, so that there may be a major accident, that is, it may burst out. So this is the hard timing constraint. So consider soft timing constraint. The same example, that is DVD player. So in the DVD player, if we press play button in the remote, immediately the video should be played, but sometimes it may take some more time to play the video. So due to that time delay, there will not be much consequences, or there will be no serious harm. So this is called as soft real time constraint. So I hope you all understood the basics of real time embedded system, that is the structure of real time embedded system model. So if you like this video, kindly subscribe my channel and share with your friends. Thank you.